Hi guys, welcome back to the Astro Imaging channel. Tonight's session by Jasem Mutlak on the Ekos Astrophotography tool. But as always, before we jump into that, I'm going to show off our image of the week. Tonight's session by Jasem Mutlak on I'm hearing an echo of myself. Where's that coming from? But as always, before we jump into that, I'm going to show off our image of the week. Oh my goodness, that's driving me nuts. There we go. It was me. Sorry about that. So I'm going to show off our image of the week. Now it disappeared on me. I'm going to go full screen so I could show it off, and you guys can watch me fish around for it. This week's image goes again to Nicholas Kazillion, and that's a beautiful Iris Nebula with all the dust surrounding it. And we did have to, Nicholas, you might be out there, but we were chatting about this before the show, and we were saying, oh, it's a really cool shot. What was this taken with? And I made a guess, and it turns out it was a Zenith Star 66, which kind of surprised us.
Yep.
I'll
give you the details on it. Yeah, definitely surprising. A Zenith Star 66 with a William Optics Platinum 6, taken with a Moravian G2 8300. His guide, he used a guide scope on it also, which was surprising, with 9x50 with a QH5L2 color on a Skywatcher as the Q6 GT. And yeah, it's 6 hours total with about, looks like almost 4 hours in luminance, and then RGB were all 5-minute subs binned at 2x2, so 6 hours total, and he processed it in PixInsight, and it was captured with Sequence Generator Pro and a little bit of work in Photoshop CS6.
Very cool. Yeah, you could have told me attack in a large sensor CCD, and I would have believed it in a second. I almost basically what I would have guessed, but it just goes to show you it's not the equipment, it's the imager. And Nicholas has been putting out some killer stuff recently. And we had to look up where he lived to see whether he was going to be available for tonight, but I believe he's one of our European viewers, so it is, I don't know, 2 or 3 a.m. for him, just as it is for our generous presenter tonight, Jasem, who is braving the 4 o'clock a.m. Time over where he's from. And let me steal my screen back, because one more time I'm going to do this for the first, I don't know, few sessions as they've changed it over. A lot of you may have noticed that Google Plus changed this morning, and basically they changed everything. I can't find my way around. So we're over on YouTube now. You can always check us out on YouTube. If you subscribe to us on YouTube, I think you get the similar notifications to what we were getting on Google+. But more importantly, on YouTube, where you're all going to go anyway because there is no Google+ anymore, we have a chat box. And your chat box can pop off, so if you want to watch the presentation a specific way, you can pop your chat away, just click those 3 little dots, and it pops right out, and you can utilize it however you'd like. And that is the way that I'm going to suggest you guys get questions to us. I'm going to keep my eye on chat, and I will call them out to Jasem as he goes. So that's basically all I've got. So I am going to hand it right over to Jasem, who's in the room. And Jasem, you're welcome to take it away. And you are still muted. Let's see. Do you know how to unmute yourself, or do I have to mute? Yeah, there you go.
I just unmuted. Can you hear me now?
We can hear you.
Okay, great. So hello, everyone. I'm glad to be here. It's 4:34 a.m. Here in Kuwait, so I'm sorry if I'm sloppy, but it's pretty late here. I'll just go ahead and I'll start the presentation, and you can guys interrupt me at any time if you guys have any questions. Please feel free to ask them away. So let me just go ahead and do that. And can you see the presentation?
Yes, we can. Actually, I see your entire presentation in the. I don't see the full screen presentation yet.
Okay. You don't see the full screen, right?
No, I see. Is it PowerPoint or?
It is. Yeah, it is something similar to that. Libra Impress. Let me see. Here.
Would you guys mind helping Jasem figure out what it is? I have to sneak over to the left for a second.
Let me try to do that again.
Is there a presentation mode for that? There you go. That's it.
It's working now? All right.
Perfect.
Okay, I had to reshare it again.
Perfect.
Okay. All right. So today's topic, as you guys know, about Ekos Astrophotography tool, which is something I've worked on for the last few years. So this is the agenda for today's presentation. First of all, I'm going to talk about a bit of background of myself. I promise I'm not going to spend a lot of time on that. Then I'm gonna start actually with the big picture. What is this whole thing about? Then I'm gonna go to the small parts. So we're gonna talk about INDI, which is the technology behind Ekos and KStars, and we're gonna talk about the planetarium program KStars, which I use to do all of these things. Then we're gonna talk about the observatory control with Ekos. And then as a use case scenario, I'm going to talk about my home observatory, Ekos Observatory, and how I set it up with Ekos. And it was a plan to give a live demonstration with the whole thing, but it's past 4:30 a.m. now, and we're past the astronomical twilight, so it will be hard. But I can give something in simulation. We might later on schedule a recorded session where I will do this demonstration of the observatory in action. And then finally we'll have question and answer session. Okay, so a little bit of background of me. I graduated 2004 from University of Kansas. I did computer engineering, but I also love astronomy in college, so I took a minor in astronomy. I joined the KStars project back in 2001, where it was started by astronomer Jason Harris, and it was a labor of love by him since then, until I think he left the project for other interests in about maybe 2009 or 2010. At around 2003, I had a Meade LX90 telescope, and I wanted somehow a way to control it from KStars. So I developed this initial LX200 library to control the telescope. And then at that time, Elwood Dooney from Clear Sky Institute, the author of INDI, the original author of INDI protocol, approached me, and this is where I got into INDI. So I've been into INDI since 2003, and I've been almost fully responsible since about 2005. So back here after graduation, I came back to Kuwait, where I worked, and on my free time, I worked on the Kuwait Science Club. So I had some upgrade work done to a Jerry Observatory. It's a half-meter observatory, using also not Ekos, but using INDI and KStars as the main programs for that. I also built a 5-meter radio observatory, also using INDI and KStars. I started with Ekos in about 2012, and I'm going to talk about why it took me that much time to start Ekos. All right, so let's look now at the big picture. So Ekos is a complete observatory automation and control tool. So it started up with humble beginnings just for simple astrophotography purposes, and it still has a big emphasis on astrophotography, but it can deal with the whole observatory automation and control. And it's thanks to the versatile nature of INDI, which is the back-end driver, let's say, supports something that's akin to ASCOM, but with substantial differences. It's very versatile, very powerful, and it can be used to power anything from your small observatory with a single telescope and camera to a complete professional level observatory. So you can use Ekos now on multiple platforms. So Ekos is an open source solution. It is free as in beer, and also free as in freedom. and it's available on Windows and Linux and Android. We have several clients on Mac OS X, but not Ekos, but something similar to Ekos, like Astro Imager and things like that. They work on Macintosh platform. So you can run Ekos on either the or KStars rather. You can run it on your desktop, or on your tablet, or on your mobile devices. We don't have any iOS versions yet. I'm not sure if you will ever have any. It's kind of hard to develop for iOS when you're developing open source applications. So using Ekos, you will sit at one place, the client side, and then it gives you the ability to remotely control all your equipment on another side. And so using something as small as a Raspberry Pi or a single board computer, single board computers, you can really run the whole observatory. You can also have a dedicated computer, like a laptop or a full-fledged server. But really, as single board computers get more powerful nowadays, and the ARM processor is getting more powerful as well, it's getting more manageable to control all of these devices with a single board. So let's talk about INDI. INDI is the backend infrastructure for the whole thing. It's what drives all this equipment. So what is INDI? So INDI is an open XML controlled protocol. It's a protocol that communicates commands and messages between the devices, your hardware, like your telescope and your camera, and the front-end GUI client where you issue these commands. It has a server-client architecture. So again, because you have a server running at one side, the server is actually the one that is directly communicating with the devices and controlling them. And then you have, on the other side, you have the client software, which could be anything from a GUI client or a script or whatever that you can have it. What's really nifty about INDI and why it's really why it's very interesting is that it decouples clients from drivers. So there is no tight coupling between the GUI client and the drivers. In fact, what's really interesting is that the clients have really no idea about the device until runtime. Until you connect to the device, you have no idea about the device itself. The thing what happens is that the device describes itself via XML, describe its properties, its capabilities to the GUI client at runtime. So for example, a telescope would say, hello client, I have something called right ascension. And right ascension is a number, it's ranged from 0 to 24, and this is it. There is also another number called declination. Or I have a text called port, or I have a text called object. So it describes itself in runtime. The benefit of this is that if any changes happen on the hardware side, the GUI client doesn't have to be changed. It can run all the time because it discovers the device's capabilities at runtime. Another really nice feature about INDI, which is not available in other control platforms, is that not only it's multi-platform, it runs on Windows and Macintosh and Linux, it's also multi-architecture. So you can find it on 32-bit CPU, 64-bit, ARM, and also a host of other architectures. It was built from the ground up to be network transparent. So as far as you're concerned, it doesn't matter if you're connected to your observatory, a few meters away, or if it's a few thousand kilometers away. It is really network transparent, and you don't have to have any third-party programs or do any tricks in order for it to work properly. It's very transparent when it comes to that. And finally, it has the end-to-end topology. So this is just geek talk to say that you can have any number of servers connected to any number of clients, connected to any number of devices. So you can create this sort of like a mesh network where multiple things. So for example, you can have, two servers controlling two different equipment, and these two servers can be changed together and controlled by a single GUI client. You might have these two servers in different geographical locations, but as far as the client is concerned, once they are changed, you are essentially connected to a single server. So it has this really nice topology which allows systems of different genre to be connected and hooked together. All right, do you guys have any questions right now? I'm not hearing any sound or feedback.
I haven't seen any questions yet, but ask your questions in chat. We're already...
Alex had a question in chat.
Okay, because I can only now see the presentation, so I'm not sure what's going on.
Yeah, I can ask that question, Mark. You showed us you showed us a picture of an observatory with a bunch of equipment around it. What was that? What observatory was that?
Oh, this is just a stock image. It's not a. You're talking about this one here, right?
Yeah, right.
Yeah. This is just like a stock image.
Is that the James Ocean Telescope? For Samuel Ocean?
I think so. Yeah, I can read that now.
Yeah. That's what I thought. Okay. And you're not implying that your equipment or your software is being used in there, are you?
No. I mean, I just Googled some stock image for Observatory, and maybe I should have used one of the observatories that we already have, but yeah, this is what happens when you do things late.
Okay. I was just wondering.
Yeah. You guys have any questions? Any further questions, or should I?
Nothing else yet.
Okay. All right. Excellent. Okay, so let's talk about INDI server. So INDI server is the traffic and routing manager. It takes your commands that's coming from the client and routes them to the appropriate drivers, which then route them to appropriate device. It's a client can connect directly to a driver, but usually having an INDI server in the middle, helps a lot in routing all these messages. As I mentioned before, it's already chainable to other INDI servers. So if you have 2 or more INDI servers running at different locations or doing different stuff, you can chain them together to form a single server as far as the client is concerned. It also supports dynamic startup and shutdown of drivers. So it's not, when you start an INDI server with a set of drivers to control a set of equipment at your observatory, and let's say that later on you need to bring up a device, then no problem. You can dynamically start it and add it to the server. If you need to dynamically shut down a device and run it later, you can also do that. So it's not rigid in that sense. When it starts, it has to stop. It can dynamically, control the devices at runtime. And one really nifty feature, really critical feature of INDI server is that it can run on headless systems. So you can run it on these small embedded devices, like the Raspberry Pi or the Odroid or a number of other single board computers, and you don't need to have any GUI. It can the server can be there doing its business, and then you can have your GUI on your mobile phone or your tablet or your desktop PC. So this separation gives a lot of versatility in where you place your server. So, I mean, an example, instead of having your laptop outside on a cold night, doing connected to your system, and it might get too cold or it might get damaged, so you can have this, small single board computer PC outside there. So if it gets damaged, then the loss is not that big if you lose your laptop or your PC. I mean, that's one way. There are other benefits, of course. It's a lot cheaper than getting a MacBook Pro or a desktop PC. Okay, so the final part of the INDI puzzle here is the INDI driver. So we talk about the clients, we talk about the server, and now the driver. So the drivers is actually what communicates with your hardware. So for example, we have EQ mod driver, which communicates with the telescope, running the Skywatcher protocol. So as I said, that the driver describes itself to the client, whatever that client may be. And so the way it performs that is that it decomposes all its functionality into simple properties, whether it's text, number, a switch, a light, or a binary blob. So as we say, like to describe the right ascension and declination value, that's defined as a number. to describe the tracking settings. Are we doing lunar or solar or whatever? You can describe that as a switch property, and so forth and so forth. If you are a CCD and you want to send an image back to the client, then you can send that as a binary property. And all those properties are sent over XML. The drivers as well, they snoop other drivers for useful information. So a case in point here is, for example, we have a GPS driver that can connect to a number of actual GPS hardware devices. And you can have the telescope driver snoop the GPS driver for current location and current time. And so the mount driver can snoop that information or read it from the GPS driver and then update itself. So drivers also have these capabilities. But in essence, the drivers is the thing that, the piece of software that communicates with your device directly. And so if tomorrow we need to make a change to the driver, it simply needs to change its interface to expose more properties. As far as the client is concerned, it doesn't really need to be changed at all. It will just read these new properties, and then in runtime, it will dynamically construct a GUI appropriate for this new property. Okay, so the INDI client is what communicates with INDI server and display the driver properties. As I said, now they can, usually it's done in a dynamic fashion. The clients are available, of course, on all platforms, or on all major platforms at least, and on multi-form factors. And you can have, clients in INDI are not strictly, rigidly defined. So you can have a lot of classes of clients. You can have GUI clients like KStars or Ekos or Astro Imager. These are GUI clients. They represent, a graphical user interface to the user. They reflect the knobs or the buttons, the switches that you press on to control your device. You can also have watchdogs clients, and what these do is that they monitor your observatory and then make sure that everything is in check, that everything safety-wise is in check. Otherwise, they take or perform some actions to prevent any harm done to your observatory. So, for example, you can have a watchdog client that monitors the weather, and then it will, if there is any problem with the weather, then it proceeds with a shutdown procedure. You can also have loggers. They just connect to the server, listen to the clients, listen to the drivers, and just log information for whatever purposes, analytical purposes you have. And also you can have simple scripts. We have INDI has Python bindings. You can write INDI in Java and Bash. You can have all these scripts doing all sort of stuff, and they're considered simple clients. So far, up to date, we have about 22 published clients. Something like PixInsight just recently added an INDI modulo client, and they're expanding on that. Now they're starting with a simple CCD capture, but they want to do it more. We have clients for OS X, Astro Imager and Astro Telescope and Auto DSLR. Of course, we have KStars, OpenBHT, and a host of other programs, and they're all communicate with INDI in one form or another. But I mean, today, since I'm the maintainer of KStars, I've been handling it for the last few years. I'd like to talk about KStars Planetarium, because Ekos is actually part of KStars. So I like everything to be in one package just to make it easier for myself. So just quickly, let's talk about KStars at a glance. Most of you probably never use KStars unless you're using Linux, Linux with KDE. But just this year in our Google Summer of Code project, we managed to release a Windows version, and now you can actually go and download the Windows version from our website. There is actually also an Android version coming up very soon. I just tested it today. In fact, So within the next few days, it will should be available on the Google Play Store. And that version is a light version of KStars, but it has INDI support, so you can use it and connect to your telescope or camera and use it just like regular KStars. So KStars is a graphical simulation of the sky, and with add-on catalogs, we can support up to 100 million stars. We're using the USNO Nomad for 100 million stars. We have over 10,000 deep sky objects. That's a stock what comes with KStars, and of course you can expand that with add-on catalogs. Of course, and we have all the solar system bodies, the comets, asteroid, everything like that. You can control KStars by a scripting, or by you can adjust the simulation rate. Of course, it has a complete astrophotography workflow via Ekos, which I'm going to talk about next. Also, if you like to do a lot of calculations, it has a module to do a lot of calculations that predicts conjunctions. It can plot time variations. It can tell you which objects are available tonight. It has wizard to help you to locate objects of interest according to the light pollution level of where you live, and things of that nature. It has a powerful observation planner to plan your observations. So you can select a host of objects, put a number of criteria of where you want your objects, their magnitudes, their location in the sky, when they're observable, altitude restrictions, and then you can build a really detailed observation plan suitable for your observation, whether you're a visual astronomer or whether you're doing astrophotography. And as I said already, we have Linux, Windows, and Android support. So why Ekos? Why did I start Ekos? The reason is in about 2012, when my astronomy passion, at least in the visible spectrum, was rekindled. So I bought about like $3,000 or maybe $5,000 worth of equipment, and after I had them for a couple of months, they're just sitting there, and I'm like, there is no coherent solution in Linux that makes sense as far as astrophotography goes. Why? Why is that the case? Because it's not like there is a lack of programs, but they are like small separate applications. You can have something separate for guiding, something separate for capture, and that something separate for capture is usually limited to a specific camera. Now, of course, by that time, 2012, we already had INDI drivers for all my equipment pretty much, but I didn't have what's a step above that. I didn't have the application to bring all of this together, because INDI drivers are just dummy software. You just use it to take a capture of an image or control the value of like the gain, or you directly control the device, but it has no intelligence to do something bigger than that as far as astrophotography is concerned, because astrophotography, as you guys well aware, has a specific or a general workflow that we take and we need to perform in order to capture our images.
Adam, I have a question.
Yes, go ahead.
Go ahead.
Can KStars show your sensor position and guide chip position for planning purposes, and the rotation angle to position a guide star?
No, it cannot show that right now, but KStars has a powerful field of view editor, where if you put your camera information, your field of width, field of view, your rotation angle, it will plot that, but it doesn't get that information from your devices directly. It's something that you have to go there and you put manually. I mean, it's a one-time operation, but you can do that, and it will plot the field of view indicator for your camera directly on the sky map.
But you can't once you do that, just change your rotation angle and position.
Oh, you can. Yeah, no, you can. Yeah, sure. Once we're done from here, I'll try to show you how is that done if we have time.
Okay, thank you.
Yeah, sure. So, and furthermore, even with these, applications running up, it requires considerable technical skills to bring them all together. I mean, I'm a 15 years plus Linux veteran, and I couldn't do it myself. It was just too much work to do. Too many, it was a spaghetti. Too many things separate. They're not coherent. They can't communicate with each other. So I just said, no, let me start this tool that would at least allow me to control my equipment that I invested a lot in, but I can't. I refuse to use Windows at that point. I still do. So I said, you better eat your own dog food. So if I'm going to use Linux, I will develop my own astrophotography tool to do that. And so thus Ekos was born. So that was in 2012. So here's a screenshot of recently that I got with Ekos. So let's talk about the features. So what is Ekos? So Ekos is the astrophotography tool within KStars. You can't run it separately outside of KStars. You have to run it within KStars. And I did that on purpose by design from the beginning. Because I really wanted a planetarium program outside there for my planning purposes, for everything. I didn't want to have something separate. I want everything like in one place, And so Ekos can control all your equipment, your telescope, CCD, DSLRs, filter wheels, everything. Essentially anything INDI compatible, it can be controlled from Ekos. If you want to know if your device has an INDI driver, then you just need to visit the INDI website, which I will link to later, and go to the devices page and check if your device is supported. If it's not supported, then you can post in the forums about your device, and we'll see if we can get it supported. Usually if there is a specification or an API for that device, then it will definitely get supported at some point. The problem is we have with devices that doesn't have any documentation of any sort or any API, or SDK that would expose its functionality to us. But rest assured, most of the major vendors, for example, let's take CCDs. So most of the major CCD vendors like SPIG, Moravian, QSI, Starlight Express, all of them, they have, INDI drivers running right now. So also Ekos have built-in native auto-guiding with support for automatic dithering between exposures. And we have, actually, I would say, we don't really support adaptive optics at this point. We have experimental support for adaptive optic devices. Additionally, if you want to use an external guider, you can either use PhD2 and soon Link Guider to do your operation. Some folks just, they're comfortable using PhD2, so we don't force them to use the internal guider. So Ekos is flexible in that sense. It allows you to use the internal guider, which is actually based on Link Guider, or at your option an external guiding application. So I mean, here's a screenshot I took recently. I have Lodestar from Starlight Express, and here's a screenshot of the guide modulo within Ekos. You can see there is a lot of options right there, like in the KDE philosophy fashion. We provide a lot of options to, fine-tune your guiding session. But most of these options are there by default. You don't really have to change them unless necessary. So most of them would work out of the box without any issues. Yeah, the next feature is really, really important, and I'm sure a lot of you guys are using it in one form or another right now. So Ekos supports extremely accurate GOTOs using astrometry.NET solver, and so we also support both the online solver where you capture an image, then it sends it to an online server, solves it, and then it sends the results back. And we also supports the offline solver. And so the astrometry.NET application runs natively, of course, on Linux, I think it runs on Windows, but it's using Cygwin or something like that. But on Linux, it's natively supported. And once you have the appropriate index files for your camera field of view, then I usually solve my images like maybe 5 to 10 seconds after I capture them. It's really fast. It makes GOTOs really nifty, really easy. You can forget about doing, 2 or 3 star alignments. I mean, as far as I'm concerned, that thing is in the past. Any application today should be able to do asymmetry solving, whether it's using asymmetry.net or whether it's using T-point or whatever asymmetry solution out there. But asymmetry.net, we're using it because it's an open source application. It runs natively, and it works really, really well. It also works very well on Raspberry Pi, despite the fact that it's computationally it's very heavy. It has a lot of uses a lot of CPU power when it performs the solving, but you can even use it on these small embedded devices. So here's a screenshot of the align modulo in Ekos, and as with the other screenshots, you might be overwhelmed by the number of options, but 90% of them are just defaults. You don't change anything. Maybe you want to change the pinning of your camera or something like that, but everything else, like the options, you don't have to touch that unless you want to fine-tune something or you want to resolve a problem. But all of these values, right distance declination, all of these values are filled automatically by Ekos. So once the only thing you have to do is you just have to click capture and solve, and then it will capture, it will find a solution, and then it will slew your mount if so desired to the desired target. All right, and if you can see here,
can I ask you a question about that?
Yeah, go ahead.
So if you want to aim at something, do you tell it where you want it to go and it will plate solve where it's at and then go to that spot and then plate solve again? Or do you have to slew there first and then plate solve on that spot?
That's a very good question. There are two options. The first one is that you slew to that point, and so it knows what's the right ascension and declination of the telescope or of the object you want to go to, and then it solves it, and then it syncs the mount, and then it slews them out to that target. Another thing you can do is you can, if you see here the button lewd and slew, so you can use like a FITS image that you captured the other day, and you can just put it here. It will solve it, finds the center point of that image, and then it will slew to that point, in the sky.
So for that one, would you need to load a different, I guess, indice for that?
Sorry?
So for that, if you were grabbing a picture off the internet, for example, would you need to load different indexes for the solving for that, or can it do something similar to a failover to a blind solve online and then bring your scope there?
Yeah, I mean, I'd probably use the online solver if I don't have my indexes. Like if my indexes are very limited, then I'll probably use the online solver. But yeah, I mean, I never used actually an external image. Because I usually frame like an image and then I use it to slew and solve it. But if it fails, I mean, this is something is by trial and error. So you try to load and slew to one. If it fails, if it can't solve it because it's lacking indexes, then you can switch to the online solver, and then that will most likely, because the online solver will have all the indexes, then that should solve it fine.
Great, thank you. Thank you.
I have a related question that maybe I'm just not getting exactly what the process is here. When you say you have more accurate go-tos, you're not actually affecting the go-to quality of the scope. You're aiming at an object area that you think is right, and then you're plate solving and finding out if it is right. And controlling the mount to correct, and then taking a picture and plate solving again until you get it right?
Well, it depends on your mount driver. So, for example, for EQ mod, and we have also other recent drivers, they have we have a new built-in alignment sum modulo that builds a mathematical model of all the points you sync to. So, in essence, every time you do a sync, the internal model used by, for example, the EQ mod driver is actually improved.
So you're building a separate model within your software. You're building a separate model in your software, a separate pointing model.
That's correct. It's not available for all mounts. I mean, we're trying to expand it to as many mounts as we can. But for example, in EQ mod at least, which was what I'm currently using, it builds a model, and the more you sync, if you go and you can save that model and load it the next time. So the more you sync to it.
Does that mean that at the beginning of an evening or at some point after I've aligned my mount in general, I have to run a set of observations or something, a set of pictures to build that initial model?
Not every night, because if you build that model before, it's already saved and it's loaded by the driver.
Well, every time I have to set up, would I have to build a new one?
No.
It's not like running a 2-point model every time you push things around with your with the sky, right?
I mean, are you talking about a mobile telescope, like?
Yes,
or is it
one that's going to go out to the star party and get set up one night, and then I have to get it ready to take pictures.
Okay. Well, I think in that case you probably have to use a different model. I'm not 100% sure.
Okay.
If using the prior model would result in success, because the situation changes and you have new errors. You're not exactly pointing north, or your error pointing north is not exactly the same thing as last time. So the model would be more appropriate for permanent. If you have a permanent observatories, this is where you can load it every time, and you can be sufficiently sure, or you can sufficiently trust the model to be accurate and to translate the sky coordinates to telescope coordinates and take you to where you need to go.
Okay, let me ask you this. Let's say for some reason I've got a dumb mountain, or I did a poor job getting it aligned or something like that, but it is aligned in a permanent observatory, and I tell it to go to M8 and I give it the exact coordinates I want for M8, and it will go there according to the pointing model that has been built into it now. Does it then take a picture to make sure that it is in fact at those coordinates?
Yes, of course.
Okay. And if it isn't, what happens?
Well, if it isn't, if it isn't, then it will try to do the capture. Then it will do the astrometry solution, and it will add that point to the model. Of course, if you're adding,
and then will it move the scope again until it gets to the proper place?
Right. I mean, in the EQMO driver, there's options. What do you want to do with the sync points? So if you just set it to add at every time, and every time you move your telescope from one place to another, then the modeling doesn't make sense anymore, because it's varied. But if you set it at one place, and then if you move to another place, you set it, okay, do not add to the pointing model whatever syncing that comes next to you. So you can have something as simple sync, So let's say you built a model somewhere, and then you go to another star party, and then there you do your syncing. You can do your syncing without overwriting whatever pointing model that was you built previously with the EcoMod. Do I make sense, or I'm not sure if...
I don't. Let's go on to some other stuff here. Maybe we'll get back to it later. Okay?
Okay, sure.
Just Sam, I'm I'm going to interrupt you to ask some of the questions that are in chat.
Sure.
Hamza's saying, is this the same thing as the closed loop slew? And Hamza also commented that there are two different things. Closed loop slew equals slew, solve, find error, sync, correction, slew. That was the first question.
Okay,
And,
maybe I need to read that. Hold on.
yeah, I think what the general question Alex is asking is, are there two different options? One where you build a model and one where you basically just use the solve to fix the field of view?
Okay, I'm just reading. Okay, I can't see Hamza question. Is that in the chat?
In chat, yes. Let me. Here, let me. I'm gonna put it in our chat for you.
Sure.
And I think the second part was his comment.
Okay, it is the same thing as the closed loop slew. The first one is a closed loop slew, solve, find error, sync. Okay.
And that's basically all of it.
That's basically okay, because I don't see the question here.
I think there's supposed to be question marks after. Is this the same? Is it the same thing as closed loop slew?
Okay. Well, I mean, when we're talking about the word closed loop means you have sensor feedback, right? So maybe I'm not sure if he's using the word closed loop in a different context here, but as far as Ekos is concerned, you capture. I mean, if you're starting from a clean slate, there is nothing else. There is nothing in the pointing model. You capture an image, you solve the image, and then you feed the sync point to the pointing model. Now that pointing model is optional. You can have Equimode running in a similar solution where it just corrects itself to the last sync point. But if you opt to use the pointing model, then the pointing model gets built, and there are various there are more than one pointing model. There are multiple plugins. You know which pointing model you want to select, because mathematically they're different. They can have different results or different let's say efficiencies or accuracies under different circumstances. So you can select the plugin of which pointing model you want to do. Now this pointing model, after you're done, is written to disk, and the next time you run your telescope or you run your observatory, it is loaded back in. So if nothing has changed, if you're not mobile, if you're just using a peer, it will just has the same information as before. And if you tell it to go to point X or point Y in the sky, then it should go based on the prior model. If you move to another place, if you have a mobile observatory and you just want to set up your telescope somewhere else, then the model probably wouldn't make much sense, because the model assumes, when you're building a model, it builds it to correct for problems in several areas, including the misalignment from true north and things like that. And these things become variable when you start moving the telescope around. So I don't believe the model will be sufficient for a mobile telescope. Having said that, if you're using Ekos, then no problem. You just run it. I mean, myself personally, I just run it one time. So I just go to if you're just on one side of the meridian, I never had to use it more than once. It's that good. So I just go to one side of the meridian, solve an image there, and voila. And then my next point is very, very accurate usually. So I hope I'm not sure if I made things more confusing or more clear now, but let's go back to, unless you guys have more questions, I'll just go back, if you don't mind, to the
Go back to your presentation. I'm going to save a lot of these questions for the end.
Sure, that's good. All right. Now let me see if I can find the. No, that's not. Hold on. Okay, are we there? I guess. Yeah, but it started. So we talk about INDI clients because. All right, so yeah, we're talking about the astrometry solver. And so with the same astrometry solver, it also helps you to do to correct for polar alignment errors. So it will ask you to measure the azimuth and altitude errors at selected points in the sky, and it will move the mount ever so slightly in declination and measures the difference there using, of course, by solving the image. And then after that, it will tell you how far you're off, either in azimuth or in altitude. So that's pretty straightforward. It also supports, Ekos supports O2 and manual focusing using the HFR or half-lux radius method. And so this method is probably a bit better or than using the FWHM or full width at half maximum method, because HFR is not is more resistant to changes in the seeing than the FWHM. So it's so HFR is or HFDs are a more reliable indicator, so you can get your focusing better with this method. And also Ekos supports in-sequence focusing. So other applications, they can give you do you want to do refocus if the temperature changes, or do you want to do refocus when the filter changes, or they give you a lot of options on what to do. In Ekos, I just made it simple and just said, besides filter change, which is an obvious thing to do, all other factors I just made it into HFR. Is the HFR value different? Is it bad? If it is, then yes, please refocus again. I already talked about load and slew. So if you have an image, you can load it there, especially if you framed the image the previous night. You can load it there, and then it will the Ekos solver will solve it for you, and it will go to that target coordinates in the sky. It also Ekos supports multiple driver profiles, so you can have either local profile for your local instruments. You can have multiple profiles for remote setups, and you can switch among them transparently. This is a nice feature of Ekos, which if you're doing observation and your mount needs to flip to the other side of the meridian, but you already have you already done the calibration, you're doing the guiding, and you don't want to stop, you don't want to flip and then do the guiding again and do the alignment again. Ekos actually does that all for you automatically. You just have to specify when you want to flip, and when the capture is done, whenever image is done, and the hour angle that you specified is exceeded, then it will initiate a flip, and then after the flip, it will do it will redo the alignment, the calibration, and the guiding again on the other side of the meridian. It will also do refocusing as well. Another nice feature of Ekos, it has automatic flight field capture. So you just set the desired ADU, and Ekos will does the rest. It will calculate, using maybe one of the method least square values for the desired ADU, and it will just capture the ADU that you want. Currently, this feature only works on CCDs. It doesn't work on DSLRs. mostly due to their nonlinear, response curve, and the simple equations that we're using are pretty linear. So we might have to tackle DSLRs at some point. And of course, no astrophotography tool is complete without a sequence, manager, how to sequence your astrophotography images. So Ekos supports a powerful sequence queue for batch captures of images. You can, name your files in a variety of ways, select the filter wheel, select the temperature, etc. This is a screenshot of the capture modulo in which it shows, the selection. So the selection of the options are on the left side, and the sequence queue is on the right side. And of course, you can save the sequence queue or reuse it at any point in the future. So framing. So this is a benefit of using the astrometry solver. So whenever you capture an image using the astrometry solver, and you want to frame it, you want to a particular part of the image, you want it to be in the center. So instead of fiddling with your mount and moving it left and right at different speeds and recapturing the image, you simply right-click anywhere within the captured image, and you say, please center here, and the mount will simply go on center at your desired location. And of course, to top it all, we have a completely automated scheduler, and I guess automated scheduler maybe is redundant, so schedulers should be automated. So the scheduler is to control all your observatory equipment. It starts from the start to the finish. It selects the best targets for imaging, giving the current conditions and constraints, giving even the weather conditions. So you can just have it running, and it will capture your data until you wake up the other day. It has shutdown procedure, startup procedure. As we see here, this is like the scheduler. So the scheduler is not something that's really complex or advanced. But for all all practical purposes, it supports the majority of what the average astrophotographer wants to achieve. So you can see you can set up the startup conditions. When you want to start your observation, you can set the constraints which have to be respected during the observation session itself. And then you specify the completion conditions. When is this supposed to be complete? Also below here you can see we have the observatory startup and shutdown procedures. We usually have this generic procedures like on-park dome, on-park mount, etc. like that. We also have shutdown procedures. So for example, you were talking earlier, Adam, about if VHD2 goes crazy, you have to go and shut down things. So if you're running here the scheduler and the guiding fails and continues to fail, then this will trigger the shutdown procedure. So it will automatically go and park the mount, park the dome, and do whatever is necessary. You can even see here that you have optional scripts that you can plug in here, because each observatory is unique in its right. You might need a startup script or a shutdown script unique to that observatory. So an example, in my home observatory, before I start up anything, I need to turn on the power because the power is usually off. So I usually turn on the power to my equipment using just a simple Python script, and then after that I proceed with the unparking of the dome, the mount, and the dust cap. So we already saw that before in the capture screen here. I'll show you. Here you can see guiding deviations. So if the guiding, sometimes you have bad images to do bad guiding. So instead of throwing these images away, Ekos will throw them away for you beforehand. Excuse me. So if the guiding deviations exceed a certain preset value by the user, by you, then it will automatically abort the exposure. It will wait until the guiding stabilizes and go below a certain threshold. So for example, here I have 3-second RMS. So if the guiding goes below this threshold, then the exposure is automatically, is resumed again wherever you stopped. So that's also a really nice feature. So you don't have to go, throw away those bad images that you have because of bad guiding. We also support dome slaving. So if you have a traditional dome, the INDI dome driver supports dome slaving. And of course, all of these features are completely integrated with KStars. So if you see an object and you want to observe it, you just right-click on it and tell it, slew there. There is a complete integration between Ekos, INDI, and the KStars. It's fully scriptable via dbus. Dbus is a protocol for inter-process communication under Linux and also under Windows. It can be used under Windows. So you can really write the KStars and INDI and Ekos interfaces. They're all exposed through dbus, which allow you to have full control of what you want to do. Finally, this is a recent feature I added. You can create and plan super mosaic images. So you can specify the overlap you want to have between regions, and how many rows, how many columns you want to have, and then EcoScheduler will create the appropriate jobs for you. So it will guide them out to go to these regions. We see here like 4 regions and capture these images for you. So this is the last feature page of Ekos. This is just an evolution of Ekos. We have, when it started in 2012, it was very, very simple, very straightforward, but it didn't do much. Here in 2016, it grew thanks to the feedback of the community. This is due to the power of open source. If a user is dissatisfied with any feature, then with some feedback, we can change things. Sometimes people or folks, submit patches, and so it gets improved by the community with time. So let us now switch gears and let me talk about my observatory, because at the end of the day, I'm just like you guys. I have to do my astrophotography, and my tool, my Ekos, has to fulfill its objectives and deliver in generating the data necessary for making pretty images at least. So I have a pretty standard setup. I have an Orion Aeon 120 millimeter apochromatic refractor. Okay, that was hard to say. And then I have the Sirius EQG mount. I might upgrade it later to a better mount, but it's been pretty good performance-wise so far. I have a QSI CCD 583 with Bader filters, both narrowband and broadband filters. For guiding, I use Lodestar X2, the new release Lodestar. It's been going pretty good with me so far. For the focuser, I use Moonlight focuser. And here you guys see the dust cap. That's the flip flat. That's the most recent addition to the observatory, and it really helps, especially doing the automatic flat fields. I don't really have to take flat fields anymore. I'm not a fan of taking flat fields. So once I had that, I can just set the desired ADU, and I have all my flat fields. And of course, I have a motorized roll-off roof, and this was by design since the beginning. And if any of you guys plans to build an observatory, please build it with a motorized roof. Don't make it as a side project to do in the future. Design it from the beginning for motorized action, because controlling it from INDI or from whatever other platform is really, really straightforward. I also have for weather, for temperature and humidity and rain sensor, I have the Vantage Pro station. And of course, I have an AC unit inside, which is also controllable from INDI. It gets to about 50 degrees Celsius here in the summer in Kuwait. So so you really have to cool down and keep the equipment cooled down, especially during the summer. You can see here in the lower right image, the roof has about like 6 centimeters of insulating materials, but that's and actually the results are good. It doesn't become an oven in the summer. But one time I had an outage, in the AC, and just after a couple of hours it can get very uncomfortably hot inside. This is the control panel, and what I have there is on the left side you can see the relay. I have the relay to control like the AC and the motor for the roof. These are controlled by symbol scripts to an HTTP server running on that electronic relay. I also have a powered or electronic remote power device, to turn on, like example, to turn electricity on to my CCD or my mount, which is you see on the left device. And here on the lower right device, you see I have the, actually this is an old picture, this is the Odroid single board computer, which is running the whole show. Now I replaced it with Raspberry Pi 3, sitting almost at the same place. All the USB connectors from the focuser, the CCD, the Lodestar, flip flat, everything, they're connected to this central piece here, which is the powered USB. Pretty much in all cases, you probably going to need the powered USB device, because connecting it to the Raspberry Pi directly, Raspberry Pi, they have four USB 2 ports. Odroids, they have the same thing, but I would highly recommend you connect it to a powered USB hub. That way, you will not get a lot of headaches. A lot of problems that we have folks reporting over at the forums, at INDI forums, they can just get boiled down to power problems. So if you want to have your observatory running smoothly, just get it there. So as you guys can see, you don't need to have any any full desktops or laptops running the show. You can have the whole thing running on a small device right there. And I think, yeah, if you guys need any more information, you can go to the INDI Lib website there. And also, if you want to have information and download links for KStars, if you go to KStars today, you'll find download links for Windows and Linux. We should be having the Google Play Store version up in hopefully less than a week. It's already, I have it already on my tablet and on my Samsung S5, and it's running really nice. But we haven't published it yet to the Google Play Store. Okay, so the plan was to give a live demo of the observatory, but if you see the outside now, it's already sunrise, so we can't give a live demo, but I can give a simulation demo. But before that, let's get to any questions.
Yassine, I actually have a couple of questions.
Yeah, go ahead.
Do you have any hate mail from Bob Denny?
Bob Denny, no.
I mean, isn't this looks like ACP? Am I wrong?
Sorry?
This looks like ACP.
Okay, it's cutting off. I just hear looks like, and then I can't hear the rest.
It looks like ACP.
ACP. Okay, yeah. Well, it's I guess it's a mesh of multiple things. It's what I do for my observation session. So I want to reduce the workload on myself. So I mean, Ekos first and foremost, I developed for myself, for my equipment, for my observatory. And then, if you see actually on the INDI forums, from 2012 until now, the picture, I mean, the stage as it is now, it's not by myself alone. It's by the the community. So the community, they say, we want this and we want that. So it just grew. It evolved to what you see right now. So at one point, maybe I think ACP is doing scheduling. I'm not sure. Is that what it's doing? ACP, the scheduler part?
It's doing just what you right. Scheduling, controlling, focusing, shutdown, startup, scripting.
Okay.
Start to finish.
All right. I thought it was doing the scheduling part only.
No, because basically when we start up, we have a script, you say run script, and then you go to bed.
Okay. Well, I don't run Windows. I don't run any Windows software. I think I read a paper for Bob about the scheduling itself. You know, using a heuristic scheduler because I was interested in the the scheduling parts itself. So this is as far as I'm concerned. I never used ACP or but I think I've seen like screenshots of it. But I always thought it was like a schedule. But ACP is a great software from what I heard. And again, Ekos is a really simple scheduler. It's not something as fancy as ACP. It will probably never reach ACP in terms of complexity and versatility. But it's good for doing simple astrophotography runs.
It actually looks pretty good to me, especially if you're controlling all these devices, including startup, power, and shutdown.
Exactly, yeah. As I said, in my observatory, I really need. I mean, the startup. For the startup alone, I need to turn on the devices. I need to check the weather. Like I actually run the weather driver and I check the weather parameters. And then after it's all good, then it proceeds. If the script returns, like 0 or -1, or I mean, say not 0. If it returns -1 or 1 or anything non-zero, then the whole procedure reports. It says, sorry, the startup procedure failed and I cannot continue. But once it succeeds, then the whole thing starts rolling.
One of the comments coming from, I'm going to take these comments backwards, from Hamza. ACP does multi-target long-term scheduling, a few months at a time.
Yeah. Yeah, Ekos doesn't do that.
Right, probably at the cost of some complexity, because I know it does get a bit complex. Also, ACP isn't free, and if I'm correct, it requires maximum DL, right, Eric?
Yeah, it requires maximum DL. It requires things like focus max. All it does is send instructions to these other programs.
Okay. Well, I mean, here within, first of all, are you guys seeing KStars?
Yeah, I asked a question earlier about can it frame an image and get the rotation angle to put a guide star in the guide star frame. Can you illustrate that if it does it?
Well, I mean, here I can show you, for example, this is my QSI frame, for my for my camera. So I can put it here, but I don't think you can. So if you go to the QSI here, for example, you can see you can specify the field of view, you can specify an offset and a rotation, and you can of course play with this, and then you can see the results, in real time, like what happens. So let's say 45 degrees. Let's reduce the offsets back to 0. And so you can rotate it to this value now, save it, and then, oops, that crashed. That doesn't good when it happens. Okay, well, I'm running it in debug mode now. Okay. Let's see here if it restores that. Okay, so there we go. So this is, this is the modified FOV. But I think the feature you're talking about is probably is it in Cautious to Seal, which is the sky charts?
Actually, I use Guide 9.
Okay, is that a Windows software?
Yes, and it allows you to frame your object with your sensor, set your rotation angle, set your offset for your guide chip, and then identify the stars that you want to use, plus it overlays the object too.
Okay, here, well, I mean, here we have something similar to that, but it's usually used for people who do observational astronomy, we have something called yeah, it's I mean, if you're asking if I have that feature in here, no. But this is another example. If a feature is missing, then you can come to the forum or submit a bug wish list report and describe it, and you might, we might have some time and develop it. This is how open source works. In here we have something else, a beta feature called Simulate Eyepiece View, but this is usually not meant for observational. But you can put your camera here as your eyepiece, and then you can also fetch a deep sky survey image and overlay it. Okay, it's crashed again. I should probably use the, let me run the stock version, not the debug version. Hold on here. Okay, meanwhile, guys, while this is running, do you have any further questions?
One of the earlier questions, well, first of all, let me start with one of the comments. Somebody commented early on, is it clickable or does it require coding? And I think Hamza pointed out, and John pointed out that you've done a lot of work to make it much more user-friendly. But in general, does someone have to code to be able to use this program, or do you think it's out of the box, no coding necessary, you can use it to acquire your images?
Absolutely no coding necessary. I mean, here I'll show you a quick example. Here we have, here's the Ekos main setup screen. Here I have a profile. Of course, I have multiple profiles for testing mostly. But here I have the simulator profiles. So in here, you set up, what's your profile name, and you can select your equipment right over here. It's just as simple as, browsing, what is your mount. Most of the mounts are supported out of the box. And CCD, what kind of CCD you have, what kind of guider you have, domes, if you have, any dome, etc. And then after this, you just simply start INDI, so it will start the devices. Sometimes you need to start it, and then you can change some config inside there. But if you don't need to change any config, you just hit connect, and that's it. Now we're connected. But this is now in simulation. Of course, I can't. We should really run a session of the Observatory later on. And here you can see the telescope simulator icon. And then you can just simply say, right-click here. You can say, track this object. And it will show you whether it's tracking. You can go here, find information about your mount, the aperture, the focal length. You can, control all of things here. If you want to capture an image, you simply go to the CCD. You have here default parameters, and let it just reach its designated place here. And if you let's go also to the line modulo. So if you notice here, once it gets to the line modulo, it will update the options and the right ascension declaration. There we go. It just did that. But if you go there, you click preview, and this is a simulation, of course, simulation of the star field there. If you want to do focusing, so for example, let's make it awfully out of focus. All right. So if you want to do the focusing, you can simply say, auto focusing, start focusing, and then see it automatically selected the star. And then it's trying now to do the auto-focusing part. Okay, here with the step size, it actually didn't do the auto-focusing here. The step size was too small for something that is really far away from focus. And actually, I think this needs to be 60,000, not 60. So let me make the initial step size larger, because for the autofocus to work, the initial step size need to reflect a change in HFR that can be detected by the algorithm. If you put a small change, then it cannot detect a change in HFR and it cannot focus properly. So let's repeat that with this value. There we go. You can see the relative profile of the HFR value. You can see sort of like one part of the V curve here, and it's decreasing. And now it's completed the autofocusing. If you want to do the guiding, sorry, not the guiding, the astrometry. Now, of course, you just can come here. If you click here, WCS, this will encode the world coordinate system, which is just a way to see the right ascension and declination within the FITS image. So let's go ahead and let's try if we can do. Let's set the pinning one by one, and let's capture and solve. So it's capturing 5-second exposure. Oh, I resorted back to this is the saved value of before. Oh, there. Hold on. This is done. This is done yet. So now it's captured an image and it's solved. Actually, that was really, really fast. It's solved within a second or two. And the reason it's solving very fast is because Ekos is smart enough to limit the search area for the astrometry solver to a narrow area in the sky around where you're actually looking at, and so it solved it. This is for the guiding. The guiding is also very simple. You can do, and here everything in Ekos is automated. So, for example, it selects an auto star if it can. So let me see that. So, for example, here the guiding, it's already selected the star. You don't even have to select it, and now it's performing the calibration step. Once the calibration step is done, then you can go ahead and start the guiding. Now, if you come here and you use the scheduler, I had a scheduler file already loaded up for IC5416. If you run the scheduler, then the whole thing is done by the scheduler automatically. So it will, start up the observatory. It will do the focusing. It will do the alignment. It will do the guiding. It will do all this for you. You don't have to, intervene. If a problem happens, then it will just move. If a problem happens and it becomes a problem, Ekos will try to, repeatedly, try to solve the problem in one way or another. But if it fails, then it will just eventually go to the shutdown procedure. For some issues like weather, so if the weather becomes dangerous, then it immediately goes to shutdown procedure to protect your equipment. Okay, I think, and of course, in KStars itself, I think it's very, very user friendly. You can go to the observational planner, look at stuff. Of course, you can see now we're past the night now. Yeah, this was the Cocoon Nebula. You can, for example, look at the altitude versus time, so you can probably plan your when you want to observe it exactly. It has, the KStars itself will take a whole session just to explain in detail, but there are plenty of tools here, that will help you to do your observation session, whether it's for visual observation or whether it's for astrophotography. We also support a lot of standard features that come with other programs, for example, like different color schemes, for night vision, things like that. That comes, standard with with the things. We have different projection modes. I think I'll stop now. I don't want to guys bore you with the details of KStars. Go ahead and download it now. You can download the Windows version if you guys are on Windows. You can also download the Windows version. Also comes with Ekos, but it only comes with Ekos in client mode. So you can, using the Windows version, you can connect to an INDI server running on a Raspberry Pi. If you use the Linux version, then you can, run INDI server locally, because INDI server cannot run on Windows right now. At least INDI server I'm handling. But I mean, it's the KStars window is fully fledged feature, just like the one in Linux. Okay, so
Yasim, I shared a screen. If you want to click on that red screen, that's the kind of display that we get, and it's very useful for planning, for guiding with the AO. You get the right kind of star in that window and get the right rotation angle.
Yeah, that's really nice. Yeah.
I mean, otherwise, if you don't get the right kind of star, you're never going to get AO guiding. Listen, it's been very interesting. I'm going to have to read this, but I've got to run and get a session going. So thank you very much.
Yeah, sure. Yeah, please try to share the idea with us on what we need to do.
There's been a nice conversation about a few different topics in YouTube, but I don't think it's something we can even cover. It's a bit more complex, and I think it's probably more appropriate, probably for your forum, which does exist, by the way. And if you do have questions on running stuff like that, go to the forum and you can check it out there. One of the stepping back. One of the earlier questions was, in case of clouds moving in or something like that, do you have error recovery? So, for example, clouds move in and then you want to fix something. Do you have options for stopping the session and then starting the session back up, or something goes wrong? Are there ways to kind of recover?
Well, yes and no. So as I showed here, let me go back to KStars. Let me share that again. Hold on. So let me go back to entire screen. Okay. So if you go here to the CCD, to the capture module, you can see here the guiding deviation must be less than this value. So let's test this out. Let me add a few exposures here. So let me add this here, and let me put a different filter here, and let me put luminosity here, and let me go to the guide module, and let me start the guiding process. Okay, so now it's doing the guiding process, and now, of course, because this is simulation, now this is perfect guiding. And actually, it's not perfect, because there is in the simulation also some form of periodic error injection that we're doing right there, but it's very minimal. And so let me go here, and then let me start the sequence queue. Okay. I should probably make these, the exposure maybe like something like 30 seconds, just to illustrate that. Okay. So let me go ahead and start the sequence queue. So now it will start, capturing the image. Well, if I go to the INDI control panel here, I have in the simulator, I have this trick to make the position go bad, so to move the telescope around. So let me do some periodic error somewhere here, and you can see here we have a big spike in the guide module, right? And the guide module after that recovered to its position, as you can see. Back in here, okay, maybe it was too quick. Let me do that again. Back here, see, it aborted because the guiding deviations were big, but then it recovers and restarts, the progress automatically. Of course, it doesn't restart from zero every time. I mean, if you capture the first image, then it will start from the second image and so forth. So if the clouds come, I guess that depends. Are they like transient clouds? They're coming, and the guiding goes crazy for a little bit, and then it goes back normal, or do they like linger for a long time? If they lingered for a long time, then if you're using the scheduler, it will go to shutdown mode. But if they're very transient, and if they last for let's say 30 seconds or less than 30 seconds, then the guide modulo has the capability of recovering the star, and once it does that, it will signal to the CCD modulo that the guided deviations now are less than this RMS value, and it will resume the exposure. Does that answer your question, or?
Yes, it actually does. That sounds like pretty good error handling. I'm sorry, I'm just reading through the questions, the additional questions. I know we've gone a lot later than you probably intended to, so we may, as you mentioned, try and do a live demo of this at some point.
Yeah.
I don't know if anyone else had any additional questions in the room. I think most of the other...
I have a question about dome.
Go ahead.
I'm wondering, does the dome driver follow the telescope, or does your software send the dome to the final destination?
The dome driver itself, let's do that. The dome driver itself has parameters for the dome, and it also snoops on the telescope. So, for example, once the telescope starts moving to a different location in the sky, let me just run here. Let's say I have a dome simulator here. So if you go here, if you see the INDI, are you seeing the KStars screen?
Yes, we are.
Okay.
Yes,
so if you go here, if you go to slaving, you can see here there is a few measurements of the shutter width. If you have a shutter, and there is a few measurements which are all documented that you need to input here. And also, if you go to the options, see it's snooping the telescope. So once the telescope starts moving to a different area in the sky, then the dome has some math inside of it, the dome driver itself, and it will go and follow, the telescope to the desired location. I'm not sure if we can demo this right now in simulation. Let's.
My question was that, let's say if you do a meridian flip, does the dome do a 360?
I'm not sure about that.
Or does it just move 10 degrees to the left?
I guess that depends on your dome driver. Each dome is unique. Sometimes you have a dome that can only return like 360 one time, and to be able to go to the other side, it has to return back because of cables or things like that. Some other domes are pre-rotating. So the thing is that the dome, the dome slaving the dome slaving just says, well, the telescope is looking at this point in the sky, so the dome usually have an azimuth value here. Like for example, we're looking at it now. It's east or 90 degrees. Okay. Let me see here if the slaving is enabled. So let's go to like M32 for example. So see, the dome is already synced and moving into this direction. See, now it's actually moving. It's not in the graphical representation, but you can see it's slowly moving to the azimuth of wherever the telescope is now. And I'm not sure about the calculation, because here I just said that the dome is 5 meters wide and it has a shutter width of 1.5 meters. In a real dome, With a real telescope, you're going to have to put all the other parameters exactly as they are in order for the calculations to be correct. Again, I'm sorry if I didn't answer your question, but I guess whether it will do 360 or 10 degrees would probably depend on the dome itself.
Okay, thank you.
Sure.
Okay. Well, we've gone a lot longer than I think we had intended to, so I am going to invite Jasem to come back, and we'll try. We're probably going to have to schedule at a more convenient time for him. I'll remind everyone it is 5 a.m. for him right now, I believe. Maybe 6 a.m. Yeah, 6 a.m. So he was generous enough to not sleep tonight, just so we could get an idea of the presentation or what his software does. But it's really a great tool. And for those of you that are watching chat, you can see there are some advocates in chat who really utilize it in the fullest. If he does come back, we're going to do it at a different time. But I'll let everyone know, and of course it will be recorded, so you'll be able to check it out at any point. Jasem, do you have anything else you wanted to cover? Otherwise, I'm going to probably end the session and allow you to either get some sleep or get some coffee, whichever you prefer.
No, thanks for having me, and I hope you guys find the software useful.
Definitely. Yeah, thanks again for coming, guys out there. Thanks for watching, and we'll see you next week. I don't have a schedule. I don't have a session planned for next week yet, but I'm thinking we might do something on binning. That seems like it'd be an interesting one. But thanks for coming, and we will see you next week. Thanks again, Jasem.
Okay, thank you. Bye-bye.